Hi everyone, I have a question for you. When you look at your combination lock, we call it a combination, but is it really what it claims to be? That's one of the questions I want to have you think about today and that we'll answer by the end of this lesson. So to get us started, I want you to go ahead and copy down the definition for a factorial. This is one of the topics we're going to be looking at today. So go ahead and pause the video and copy that definition down. So now that you've copied your definition down, a factorial is really just a shortcut way for mathematicians to write out that you are going to multiply all the numbers until you get down to the number 1. So 8 factorial is the same as taking 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And so if we want to be even more specific, we could say that we are counting all of our integers from the number that we start with down to 1. Okay? So how does it work in terms of calculations? Well, we'll work a couple of these out together, and then I'll just have you pause the video and try a couple on your own. So something like this, if you have 5 factorial over 3 factorial, that means in the numerator, you are taking the number 5, and you are multiplying starting with 5, all the way down until you get to the number 1. And before we actually perform that multiplication, we're going to simplify a little bit. So 5, 4, 3, 2, 1 in the numerator. And then in the denominator, 3 factorial would just mean we're taking 3 times 2 times 1. Okay, so we use a little common sense and a little logic here. The 3 in the numerator will cancel with the 3 in the denominator because multiplication and division are inverses. Same with the 2, same with the 1. And so instead of typing all of that into your calculator, realize after simplifying, we end up with 5 times 4, which is the same as 20. And eventually this is going to tie into that question that I posed on the first slide. All right, the next one, very similar. Just want to have you try a couple of these so you can see how the number calculations end up simplifying. So when we go to take 9 factorial, I get to cheat because I'm on a laptop and take the shortcut. But basically what we're going to do is we're going to start at the number 9. And we are going to multiply all of our integers until we get down to the number 1. So in the numerator, that's what we end up with. In the denominator, I'm just going to copy the part I need. Again, thank you, technology. Okay, so we end up with this. And the 5 will cancel out. 4, 3, 2, and 1. All of those are going to cancel. And so we end up being left with only 4 factors. Remember, factors are things that are multiplied. So 9 times 8 times 7 times 6. And I don't know what that is off the top of my head, so I'm just going to type it into my spotlight. 9 times 8 times 7 times 6 is 3,024. And that's as simple as we can get that one. All right, go ahead and pause the video and try the last 2. When you get done, you can certainly fast forward through and see what you come up with. Otherwise, if you still need a little more guidance, just go ahead and watch the next 2 examples here. All right, so for 6 factorial, I'm going to take 6, 5, 4, 3, 2, 1. And there's 2 parts to the denominator now. So now we have 2 factorial, which is the same as 2 times 1. Okay, but we also have a 4 factorial. So both of those parts get multiplied in the denominator. So this is what we end up with. And so the operation between those 2 is multiplication. All right, so same as before, anything in the numerator can cancel with anything in the denominator. So 4 on down drops out. So we're left with 6 times 5, which is 30. 2 times 1 is 2. And so we have 30 divided by 2, which is 15. Okay, and then on the next one, 8 factorial would be the same as 8 times 7 times 6 times 5, 4, 3, 2, 1. So that goes in our numerator. And then the denominator will have 4 factorial twice. So 4 times 3 times 2 times 1. And then I'm just going to repeat that. 4 times 3 times 2 times 1. Okay, so this one, let's see what we can do here. We got 4, 3, 2, 1. That's easy to drop out. I noticed that 8 in the numerator is really just the same as 4 times 2 in the denominator. So 4 times 2 is 8. I can cancel those out. The 4 and the 2 cancel out with the 8. I notice that in the numerator then, I'm left with 7 times 6 times 5. And actually, we could even go a little further on that because 3 and 6, even though they aren't the same values, they reduce. 3 goes into 3 once, and 3 goes into 6 twice. So if we reduce first, the mental math is a lot easier. So we're left with 7 times 2 times 5 in the numerator, and everything canceled out of the denominator. That doesn't always happen. I know 2 times 5 is 10, 7 times 10 is 70, and then our mental math is a lot easier to work with after canceling. I caution you with just throwing this all in the calculator because sometimes you get, excuse me, sometimes you get numbers that are too big for the calculator to handle, and so you really have to learn how to cancel this before you type it all in the calculator. Okay, so now that we've kind of learned how to do the calculations, I want you to start thinking about these 2 words that we're going to be introducing here in a minute. But we want to connect them to things that we're a little bit more familiar with. So think back to the good old Simpsons. I'm sure you've all seen The Simpsons. We got Bart, we got Krusty, we got Maggie, Lisa, and Homer. And so take a minute to write those 5 names down. And when you're done, turn to the next slide. All right, your job is to think about all 5 of these characters, yes, characters, going for a run, and they're going to race. And so we're going to hand out prizes for first and second place. What I want you to think about is how many different results can we get for this situation, okay? Now, some of you are probably already thinking about this, but keep it organized. And at this point, again, pause the video, and I want you to try to come up with your organized list. When you feel confident you have all your items, go ahead and hit resume, and I'll show you my list. All right, so welcome back. This is the list that I came up with. And if you notice the way I organized it, I took Bart and had him finishing first for all of these what are technically called permutations, and we'll talk about that in a minute. But Bart finished first, and then I just paired Bart up with Krusty, Maggie, Lisa, and Homer. And then I said, okay, well, the next column, what if Krusty finishes first? And I paired him up with all the 4 others, and so on, continuing with Maggie, Lisa, and Homer in the same fashion. So I was able to come up with 20 ways. If you didn't get 20, it might help to organize your list this way, and then you can see all 20 options that we have. So like these 2 look relatively close to one another, but notice in this one, Bart's going first and Krusty second. Well, it's a different finish than if Krusty gets first and Bart gets second. So when order matters, we technically don't call it a combination of events. We call it a permutation. And the way that I remember that is I always say, remember your pom-poms. So if I highlight a couple keywords here, oh, that didn't really work. Let me try a different color. With oh, it's not working either. Let's try blue. Striking out. Okay, I guess we'll use the pen tool. With permutations, I'm going to circle the P. Order matters. So with permutations, order matters. That kind of spells like pom-poms. So with permutations, order matters. Write that in your notes. Okay. Maybe another way to think about it is jobs are assigned to people, or they have like specific roles like first place, second place, or president, vice president, that type of deal. All right. Now, we're going to compare that to what you've probably heard before is a combination of things happening. But combinations occur when order doesn't matter, like when you select things. Okay, so like back here, they talked about different roles, different positions. This is considered a permutation because order mattered the way that they finished the race. So permutations, order matters. Okay, so let's think of a situation where that wouldn't be the case. All right, let's go back to the good old Simpsons. Now, we're going to pick two Simpsons, and they're going to go on a safari to Africa. How many different trios? Oh, I shouldn't say trios. I forgot I changed that. How many different pairs are there? So take a minute to think about it. When you give up or if you've completely exhausted your list, go ahead and come back and we'll watch the next part. Okay, this is the list I came up with. I came up with these items that are in black here. I called it a combination because, if we're just picking from a hat who gets to go, it doesn't matter if I pick Bart first and Krusty second. Like, they're both still going on the trip. It doesn't matter whose name gets drawn first. That's why this one, this particular situation is called a combination. And that's because order doesn't matter. Okay? So, like, Bart picked first, Krusty picked second. This one that I kind of highlighted down here, if Krusty gets picked first and Bart gets picked second, that doesn't count as a separate choice. So I'm not going to include that in my list. And so you kind of see the ones I grayed out, like LB, well, that's the same as Bart, then Lisa. So we don't want to duplicate with a combination. So in this situation, instead of having 20 choices, we now have 4 plus 3 plus 2 plus 1. So we end up with, 10 different combinations that work. So the question I posed at the beginning, is a lot combination really considered a combination? So my question is, does order matter when you're putting in your combinations? And I would say yes, it definitely does. So therefore, this is not even really considered a combination. This is really called a permutation. And so if I were in charge of the school, I would say, here's your locker permutation, because that's really what it is. It's not a combination. All right, so we've kind of introduced the idea. Our job now is to determine which of these is considered a permutation and which is considered a combination. So I'm going to ask that you try them first. If you want to watch a few, go ahead. But I'm just going to keep going on with the video. But I want you to pause it and try it first on your own. Okay? All right, welcome back. You've had a chance to look at these. The super value lunch. Oh boy, that sounds good. Deep fried Dan's. Again, super healthy. How many 3-item combos can be selected from the 20 item menu. So if we order from the drive-through, it doesn't matter which item I say I want first. It's still going to end up in the bag. So in this one, order does not matter. If order does not matter, that's a combination. So this would be considered combination. All right, if we're running for vice president and president, this would be specific jobs, specific roles. So to reference our definition, order does matter here because we're giving them specific jobs. So we're going to call this one a permutation. Okay, first 5 people show up with radio get tickets. So in this case, order does not matter because no matter what, if you're any of those first 5, you still have the same outcome. So that would be considered a combination. If you're competing for gold, silver, and bronze medals, it's kind of like the president, vice president thing. That's a specific job assignment or a specific role that you're filling. So that would be considered a permutation. Okay, and then the last one, if we're taking a photo and we look at all the different combinations of photos, order definitely matters there because it's a completely different arrangement based upon the people in the picture. So this one would be considered a permutation. How many did you get right? Hopefully you got all of them. Okay. We're going to address these questions on Monday. We will let you know what the assignment is based upon how much time we have left in class. Thanks for watching.